Didn't. We're on the next page. We're on the next page.
Oh,
yeah. Okay, so logarithms can be used to model sound, like decibels, yeah, sound. Okay, so that's the first blank that I just said. Sound. And the intensity of sound is a measure of the energy carried by a sound wave. Yeah. The greater the intensity of the sound, the louder it seems. Okay, so intensity and loudness aren't the exact same thing, but they are related. This apparent loudness L, so it just told us like a little symbol, is measured in decibels, which the symbol for that is little d, capital B. And we can use the formula, and it's supposed to have an L in front of it. I am sorry. L equals 10 times the log of I over IO. And I'll explain what those are. It explains it for us. So what's the base there in that one?
1.
No, you're
10 log.
10. It's 10. When you can't see the base, it's 10. That's a common log. Okay, and it says where I is the intensity of the sound in watts. Okay, so L is the loudness, I is the intensity. Loudness is decibels, intensity is watts. And it's actually watts per square meter. So here's the little symbol for it. I naught, when it says I with subscript O, you say I naught, is the lowest intensity sound the average human ear can detect, which on this little chart, the threshold of hearing, that is I naught, I-O. And this, I think this thing is interesting. We go up from like a soft whisper at 1 meter away is 30 decibels. And a normal conversation is 60, so it like doubles in decimals. Alarm clock is 80. And look, alarm clock at 1.5 meters away is 80 decibels. And 85 decibels is where continuous noise this loud harms hearing. So our alarms are very close to harming our hearing.
Well, if it's not 1.5 meters away, then you're dead.
Yeah. Okay, so MP3 with headphones at max is at 100. So really and truly, if you have your headphones at max, they can damage your hearing. Right? Okay. And then it goes up from there. I think it's funny. Warning: noise this loud hurts. Anyways, okay. So there we go. We are going to use all this information to kind of deal with this problem. It says a shipping company has started flying cargo planes out of the city airport. Residents in a nearby neighborhood have complained that the cargo planes are too loud. Sounds like some things people in How would say. Okay, suppose the shipping company hires you to design a way to reduce the intensity of the sound by half. That's very specific. Reduce the intensity, so that's I, of the sound by half. So we want to cut the intensity in half. And then the question is, by how many decibels? Remember that decibels go with loudness. Will the loudness of the sound be decreased? So mathematically, we're going to cut the intensity in half, and then we're going to see what difference that makes in the loudness. Because remember, they're not the exact same thing, but they're related. Woo, this is going to be fun. Okay, so let's first define some little variables that we're going to use. We're going to use I1 as the present intensity. So that's what people are complaining about. Present intensity. And that's what we want to cut in half. So our reduced intensity is, we're going to call I2. So that's reduced intensity. So when we cut that in half, it'll be I 1 divided by 2 will equal I2, right? That's our goal. Y'all agree? Okay. Then, remember, we have to figure out the effects on the loudness. So we'll use L1 as the present loudness. And that's the decibels, if you want to write that down. Remember it. And then L2 will be our reduced loudness. So we want to know the difference between those two. So we're looking for L1 minus. So what formula up above in the little paragraph that we went through, what formula did it give us for loudness? 10 log, what? I over I0. So I'm going to make this formula be specific to my present loudness and intensity. So I'm going to use L1 and I1 specifically. And then I0's at the bottom. Then I'm going to do the same thing for my L2. So I'll have L2 equals 10 log of I2, my reduced intensity, over intensity naught. The whole threshold of hearing thing. Whew, okay. So remember, our goal is to get L1 minus L2. Well, we just found formulas for each of those, right? Yeah? So I'm going to say that L1 minus L2 equals 10 log intensity 1 over intensity naught minus 10 log intensity 2 over intensity naught. We're going to simplify, yeah, and right now we have, in our formula, we have 3 different I's. We have I1, I2, and I0. Can we replace one of these so that we only have either I1 or I2? No, we can't do that. Because it's not I to the 0. It's just a label. It's a name. But up here, what do we say I2 equals? I1 over 2. So we can replace that. Oop, I'm going to go up to the top. So we can replace that. We're going to put this right here. So L1 minus L2 equals 10 log intensity 1 over intensity naught minus 10 log, and I'm going to replace I2 with intensity 1 over 2, which is the same thing as, let's see, that's a half times intensity, so 0.5 intensity 1. Okay, I'm going to write that in there. So instead of I2, I'm putting 0.5 intensity 1 over intensity naught. We're getting there, I promise. We are going to use the properties that we just did. So to break things up here, I'm going to break this apart. So I'm going to have that equal, the front one stays the same. Oops, that's supposed to say 10 log. That does not say 10 log. 10 log I1 over I0 minus 10, and I'm going to break this in half. Log of 0.5 times the I1 over I0. So I'm kind of splitting up the 0.5 and then the whole I fraction. I want those to be different. Let me put that in parentheses if it's confusing. And this is a multiplication sign. So what did the product property tell us we could do with these? Inside this big parenthesis here, we have log 0.5 times I1 over I naught. So instead of, how can I break that into 2? What would be the symbol between them? Multiplication to addition. Okay, so the front, still the same, la la la. Minus 10, and then in parentheses we'll have log of 0.5 plus log of I1 over I naught. Okay, and the reason I put it all in parentheses and kind of kept the 10 separate is now we're going to distribute this 10 to both. I promise it's about to start. Oh dear, I wasn't recording. Where did it stop recording? Okay, so this equals 10 log I1 over I naught. Distribute the 10, so minus 10 log of 0.5 minus 10 of log times log of I1 over I naught. Oops, I don't need that. What is our first term of this whole thing?
10 log I1 over I
And what's the last term?
negative 10 log
So what happens to those two terms?
I. Both go away.
They cancel each other out. Yay! And all of our i's are gone. So now we just have negative 10 log of 0.5. Hey, you can put that in your calculator. Hey, do that.
L1 is L minus 1.
Huh?
L1 minus L2.
Yeah, this will give us our answer. But you can put the negative 10 log 0.5 in there. It should be close to a whole number. Let me see. So about how many decibels difference is it?
3.
So it's about, it's not writing, hello. About 3 decibels is the reduction. So that is your answer. Okay, so if you cut anything, if you cut the intensity in half, then the loudness reduces by about 3 decimals. That seems like not very much, right?
So in other words, it would have absolutely no effect.
It have a little effect, but not much. Okay. All right. Any questions? No? Okay. Do your homework.